Okay, so earlier in this chapter, we learned about the derivatives of the cosine function and the sine function. But let's not forget about the other guys. We don't want to leave the tangent function or the secant function or cotangent function or cosecant function out. We gotta make sure we include them. So here are the derivatives of the other four basic trig functions. We got that the derivative of the tangent function is equal to the secant function squared. So the whole function of secant is being raised to the second power. Remember that this notation is just the way we do it in trig functions. So it's the whole thing. Let me actually go up to the side. This whole thing, you put the whole thing in parentheses. That whole thing is squared. So just a reminder. Now, the derivative of the secant function is equal to the secant function times the tangent function. And likewise, you're going to see that these two are kind of very similar to the ones on the left. The derivative of the cotangent function is equal to the negative cosecant function squared. Remember, this whole thing is all the way to the second power, kind of like this. And the derivative of the cosecant function of x is equal to the negative cosecant function of x times the cotangent function of x. Now, well, how do we get these? Well, don't worry, I got you. I'm going to show you right now. Let's go through these, and let's start with how we find the derivative of the tangent function. So we have our function tangent of x. So f of x is equal to the tangent of x. Now, let's remember that the tangent of x is equal to the sine of x over the cosine of x. So what we can have here is the function of x, or f of x, is equal to the sine of x over the cosine of x. And what we're going to do here is we're going to differentiate this quotient, that's right, using the quotient rule. And let's see what we got. So if we get f prime of x, remember what the quotient rule says. The quotient rule is, this is your, I guess we can't say this is our f, but this is our, let's call this h. This is our h, and that's our g. So the derivative of h over g is you first take the derivative of h, or the derivative of the sine of x, which is the cosine of x, and that you then multiply by the derivative of g of x, or no, not the derivative of g of x, just g of x. So just cosine of x. And from that, you subtract h, sine of x, in other words, and then you multiply that by the derivative of g, or the derivative of the cosine of x, or the negative sine of x. And this is all over g squared. This is all over the bottom function squared, or the cosine of x squared. And now what we got to do is, we're going to simplify this, or rewrite it, I guess. So this is equal to then the cosine of x times the cosine of x. That's the cosine squared of x, minus a negative sine of, or minus sine of x times the negative sine of x is the same as adding the sine function squared of x all over the cosine function of x squared. Now, remember the basic property, the Pythagorean theorem, where we have the cosine squared of x plus the sine squared of x is equal to 1. So we just make the top 1, and we got just 1 over the cosine squared of x. And we can rewrite this as simply the secant squared of x function. Because remember, in case you need a reminder, remember the 1 over the cosine of x from your trig days is equal to, or well, actually, I should write that. well, actually, well, I guess however you want to look at it. So remember the cosine and secant functions are inverses. So you could write this as the cosine of x is equal to 1 over the secant of x. They're reciprocal to each other, or the secant of x is equal to 1 over the cosine of x. And either way, that's how you get from here to here. So that's how we find the derivative of the tangent function of x. Now let's look at how we find the derivative of the secant function of x, or the secant of x, I should say. So we have that f of x is secant of x. So if f of x is the secant of x, since we don't know what the secant of x is, let's just rewrite this as 1 over the cosine of x, which is by definition what it is. So then what we got here is another quotient rule. We got a function over a function. So let's call this our h, I guess. Let's call that our g. Some function over another function, h over g. So the derivative of f, or f prime of x, is equal to h prime of x, the derivative of h, which is just 0, times g of x, which is just the same thing, which is just the cosine of x. And from that, we subtract h, which is just 1, times the derivative of g of x. So the derivative of g of x is the negative sine of x, all over g of x squared, which is going to make it all over the cosine function squared. Now, since this is 0 times that goes away, and then all we have left on top is sine of x. And what we've got on the bottom is really, let's look at this as the cosine of x times the cosine of x. So what you got here is that you can rewrite this as the sine of x over the cosine of x times 1 over the cosine of x, right? Because this is just 1. So basically you got two fractions being multiplied. The sine of x over the cosine of x is the tangent of x. So we have the tangent of x here, and 1 over the cosine of x is just the secant of x. So there you go. There's how we get the derivative of the secant of x being equal to the tangent of x times the secant of x, or the same thing as secant of x times the tangent of x. All right, so I hope that helps. Good luck.